So what is initially the block? There's a block and so it is kept on a rough surface. So initially spring is at natural length. Let me have this reference line. So what is the state of the spring? It is at natural length. The question given like this, and this is rough. Let's take the problem. So one end of the spring is pulled. Who will pull that? External agent is going to pull that one. So as he pulls, so when the block will shift, only when spring force overcome the friction. So therefore, what is the state of the block? Block will be here only. So an external agent, no, yes. Let's assume that one. So now shall we take this elongation as x1? So when you produce some elongation only, here spring force will act. Then the spring force can overcome the friction. Will you agree this? This is a sequence. Now what happened? The block is about to shift. For that what happened? The other end, what happened? The free end of the spring should be displaced by a distance x1. So what is kx1? Kx1 we can write equal to mu s mg. I think this is mu s. Block is about to shift, or you can put motion impending here. So here kx1 equal to keep it in hand. Then, so what will happen very next moment? The spring force is able to overcome the friction, and what will happen to block? Block starts accelerating. No? Why it will start accelerating? Here motion impending, here at rest. The block starts accelerating. So this will be the, so what about the friction? No, friction will be mu k m1g, and again still show that spring force kx1. Will I agree this? I think you must have some basic idea here by this time. The moment the motion impending, I'm telling, very next moment what happened? The force is able to shift the block, and the block as it start moving here. So what is the kinetic friction will act here? Okay, now tell me what is the state of the block? It's start accelerating. No? So now the block will start shifting here. So here, so kx some kx, you write it. Then here mu k m1g, and it is accelerating. Because of this, it will acquire velocity. So tell me what will happen to the block here now? The block will accelerate. As it accelerates, the velocity will increase, no? And at one point, as it accelerates, then at one point again the spring force is balanced by the I need some. This is mu k m1g. Let me write here. So here the spring force will balance. Oh. Without diagram, you can't understand. That's why I'm just going for this one. So kx naught mu k m1g. Here it will have maximum velocity. This is like a mean position. The force will be continuously be acting. Tell me now after this, what will happen? The spring force will become less than mu k Manji. And what is the state of the block? Block will decelerate. Block will decelerate and will undergo retardation. Will undergo retardation. So yeah, kx2 let me call. Here it will be, I'm showing retardation like this, a2. And finally what happened to the block? It will come to rest, no? I could have wrote directly equation, just I wanted to show that one. So look at the state of the spring now. So spring, what is the thing? So finally what happened? It has undergone displacement of how much? Equal to S. This he has given. And here what happened? The spring force will be acting here. So sir call say some kx3. This is the elongation x3, I'll write it. And this is what? Say L0 for our convenient. And what is the state of the block? Again, it has come to rest. Why? Because undergo retardation, the spring force will become less than the frictional force will undergo retardation, and for a moment, let it come to rest here. Okay, now how you can write overall the set of equations. So just I think the diagrams, all the point of application. Okay, fine. No, so look at the total diagram. Situation is what I'm showing it here. No? Can you write any equations looking at the set of diagrams? You are supposed to analyze. Without this, I think you'll be in a not better position to solve this problem. What all information given? First, looking at the diagram, L0 plus x1, L0 plus x1 should be equal to S plus x3 plus L0. So therefore, x1 equal to S plus x3. Now, somewhere x2 I took it, x3 is what very important for us. This should be equation. Now, what about the work done? That was the question given, no? I think read question once. The free end of the spring is pulled gradually away from the block until the block begins to slide. I'll pull it until the block begins to slide. Finish or no? Afterwards, I'll not shift it. Is it okay?
Got it.
So therefore, I should bring that red color dotted line. I think that is very important. That without that sentence, we can't do anything with the problem. Okay, now any equations can you write here? It's all about now looking at the diagram, that one. So initially, this is the elongation. No? This is the elongation. What is the state of spring? Spring, I'll write it here. This is the elongation. And what is here? Here also elongation. So what is the, so who will do work on the block? The spring force only. So work done by spring force should be equal to what? To overcome the friction. So shall I equate anything, the elastic potential of the springs with the Work done by the friction. What all? See, like, see, the problem is like this. This end of the spring is pulled, finished over. I don't displace here. Now here what when what is the energy of system? Kx1 square. Kx1 square by 2. This energy is what is utilized to displace the block. And finally, what when the spring has retained some energy. So what about here? From where this kx1 square by 2 will come? By the action agent. The action agent did some work. The system got acquired energy here. How much? Kx1 square by 2. Finished. What is the role of action agent? Now take it out because you look at the F, the point you see that one. Where is one end is pulling, no? That pull force will be like that only. So it's just keeping it here. Now what will happen? You will stretch and finish over. So what you should do here now, actually, if you're not getting confusion, I'm just going to fix it here. This is actually if I remove this F, no, you'll not understand, sir. Wow, O will pull that one. Extra agent only. So here what happens? From here onwards, you remove it. So then, sir, from O me it is connecting. You may say that it's connected to nail something. So I should bring nail, or therefore I'm just showing that F. So any work X agent will do from here, nothing, no. Then we'll do work only spring force. So initial energy in the spring, kx1 square by 2. This should be equal to what finally? Work done to overcome friction, mu k m1g into s plus k x3 square by 2. Okay, now what is the equation? We have kx1 for the block to shift. What is the basic condition? Kx1 should be equal to mu s m1g. So replace x3. I think all the information given, solving it, will get the required answer. So what you can write x3, kx1 square by 2 mu k m1gs. x3 I can write it as x1 minus s whole square. So kx1 square by 2 mu k m1gs minus k. So these two will get eliminated. So what will be left over? So we have all the information, no? And kx1 what you can write from this equation, mu s m1g. So next equation will be 0 equal to mu k m1gs minus k square by 2. This will be mu s y m1 only m, no, it is block of mass m, no. Yeah. So mu k mgs minus k square by 2 mu s mg into s. Solving this, we'll get expression for mu s as is equal to mu k plus ks by 2 mg. It's all about the situation you're supposed to understand clearly. So no work is done. Here that one. Work done by F is 0. See, in Pathfinder, questions are there until unless you should, the background you should make a clarity. Writing equations very easy, you see that one. You should understand the event, what is going on there clearly.
So,
Ah.
could you once explain, so how did you get that equation kx1 square by 2 is equal to that mu k mgs plus kx3?
Yes, look on this one. This equation, huh?
No, sir, the above one.
Above one?
Yes, sir.
This one, huh? This one, huh?
Yes, sir, yes.
Yes, like work done by this applied force. So it's just holding that end, that's all here. So what is energy stored in the spring? Kx1 square by 2. The spring force only will shift the block, no? And friction does work. And finally, it is having some energy. So kx1 square by 2 of the initial, what the spring is having, no? That should be what? A part of that energy is used to overcome the friction and the remaining will be retained. So I'm writing that equation.
Yes, sir. Understood, sir.
I'll
Sir,
give the,
sorry sir, could you repeat what you have said? How did you get that equation?
the energy here, the elastic potential is stored in the spring is what? A part of it is used to overcome the friction and the remaining will be retained in the spring.